Hello, I'm Pratheek Karnati, Security Architect for IBM Cloud. Today we are going to look at IBM Cloud Data Shield and how it enables you to protect your containerized applications data in use or in memory. We are going to see this in action with help of a demo application we built called CloudFront. But first, let's talk about data protection. We believe it requires protection of data throughout its lifecycle, in transit, at rest, and also in use. And we have been on a mission to address that with confidential computing, which protects data in use by performing computation in a hardware-based trusted execution environment. And Data Shield is a deployment time tool that helps you adopt confidential computing on x86 platforms, specifically Intel software guard extensions, with no code changes. Let's see how this works. CloudFront is a Python app we built for this demo. And yes, with Data Shield powered by Photonics runtime encryption, in addition to C++, we also support Java, Python, and Rust runtimes on SGX. CloudFront is a containerized application running on Kubernetes. CloudFront is a typical 3-tier application with an UI, backend API, and a database. For the database, we are using confidential database service from our portfolio called HyperProtect MongoDB, so it is very secure. For this demo, let's focus on the threat vectors that come at the backend API layer and how a privileged user, infrastructure admin for example, with no access to database can steal sensitive data from the backend API's memory. As a narrative element for this demo, we are using CloudFront to donate money to a charity. Let's see how it works. So I open the CloudFront application in my browser. I click Donate Now. Here I'm giving the details, and importantly, I'm giving my personal information and also the credit card number. And give the expiration date and the CVV and click Submit. Now the data goes to the backend API. Now let's see how a privileged user attack can play out. Here I'm logged into the server as a privileged user. So I have my terminal open. I'm trying to log into the worker node in question. Once I'm in there, let's find the process in question, the Python app I was talking about. Once I have that, let's find the PID. Once I have that, let's memory dump it. Now let's look for strings in the memory dump. That's a lot of data. Let's search for my name. As you can see, this is a problem. This application is vulnerable to privileged user attacks targeting its memory contents. Now, let's see how you can protect your application's data in use with Data Shield. Let's take a look at Data Shield's documentation. You start your journey in the Getting Started page. One of the first things you do is you have the right cluster, the right worker node. And you run a couple commands for prerequisites. And you install Data Shield through this Helm chart. Replace these values with the chart name, your email ID, account ID, and Ingress subdomain. And you get your dedicated single-tenant instance of Data Shield running natively on your cluster. Now, let's look at the UI. You log into the UI using your IAM token. Once you're in there, you can manage your worker nodes and look at their attestation reports. You can create apps and builds for your pipelines. You can create tasks so you can approve or deny a build. And in the user section, you can add your teammates and you can manage them. Now, let's go back to the application and see how easy it is to convert your application from its current state to runtime memory encrypted counterpart. Since Data Shield is a deployment time tool, you don't have to make any changes to your code. You make this API call from your CI/CD pipeline prior to deployment of your application. Replace these values here with your application container name and the new name for the new SGX capable image we create for you. When you call this API, since you give Data Shield read-write privileges to your container registry at installation, Data Shield pulls the current image, converts and packages to SGX capable counterpart, and pushes the new image back to your registry. Now, you continue with your CD process and deploy your new runtime memory encrypted backend API. Let's look at the changes you make to the YAML real quick. As you can see, all we need is a couple of volume mounts for SGX drivers. You can find an example of a YAML in our documentation. Let's go ahead and deploy this new backend API and perform the same steps as earlier. I'm on my terminal. I'm deploying the new API. Once it's up, let's go to the browser and do the same steps as before. I'm at the CloudFront. I'm donating to CloudFront. I gave my name, my address, my telephone number, my credit card number, and my expiration date, and the CVV, and click Submit. Now let's go back to the terminal again and try to scrape for text in the memory dump of this process. Here I am in the worker node. I'm trying to search for the process here and the PID. Once I have the PID, let's memory dump the process. Once you memory dump it, let's scan for plain text in this memory dump. And to make it easier, let's give my name. But you see nothing because the memory is encrypted. There you have it. In about 5 minutes, you go from an application that is vulnerable to a runtime memory encrypted counterpart. Data Shield helps you and your team do what you do best, developing stellar apps. Data Shield takes the burden off from the development to the deployment time and helps you protect your sensitive data in memory without any code changes. Please give IBM Cloud Data Shield a try and reach out if you have any questions. Thank you.